Yeah, exactly. I didn't know anything about that.
6.2, the standard normal distribution. That is what the first section we're doing today is about, the standard normal distribution. And then 6.3, we're going to apply that to some situations out of that. So standard normal distribution is our first section that we're going to talk about. And then we're going to build up. Chapter 6 has several sections in it, so we got a good bit to cover.
Like that central limit theorems.
Yeah, theorems are always fun. I love those. So let's get the basics going today. All right, the standard normal distribution has three properties. The first property is that it's a bell-shaped curve. Have you ever heard the bell curve? It's a standard normal distribution. The mean for a standard normal distribution is 0. Mu is equal to 0 for a standard normal distribution. The standard deviation is equal to 1 if it's a standard normal distribution. Okay. Standard normal. So when things fit the normal distribution, which law of large numbers and statistics says that as we collect data, things get closer and closer to being normalized, meaning they fit the bell curve. The average gets close to the middle. We can normalize that data and look at make the mean equal to 0, and then the standard deviation be equal to 1. I've done this before with tests. I had a professor in college that did this with tests. He normalized it. Whatever the mean was right in the middle, and that was a C. So if everybody did really well on the test, made above a 90, a C was above a 90. That's how he did it. Normalized every test. So, but it's a bell-shaped curve. So we're going to work on finding areas underneath that curve, probabilities or relative frequencies for that. That's what is related to that area with different regions. We're also going to go back and pick up z-scores. Remember we talked about z-scores a while back, so we're going to use that some with the normal distribution. Z-scores are a big part of that. So those three things are important to decide if something is a standard normal distribution. Uniform distribution, we've seen those before. A continuous random variable has a uniform distribution if all of its values are spread evenly over the range of probabilities. Okay? It's a rectangle shape. Normal distribution is a bell curve shape. A uniform distribution is a rectangular shape. Okay? Know that. A density curve is the graph of a continuous probability distribution. A density curve. So if you see the words density curve, that is the graph of a continuous probability distribution. And it must satisfy some properties, and we're going to go through that. Where this comes in nice is when you take, we were kind of discussing that this is elementary statistics, so you're getting the basic idea here. Density curves can change shapes according to your data, and you can have an equation for that particular density curve. As you get into higher level statistics, and after you've taken some calculus, let's say you wanted to be an actuary or someone who did statistical analysis for a sports team or a company or something like that, you learn to fit these density curves and you use calculus to find the probabilities because it's the area underneath that curve, and depending on your situation, how your density curve changes. Okay, so we're dealing with the uniform distribution, which the curve is a rectangle, or the bell